So rationalizing a denominator in binomial form. So remember that in order to rationalize a binomial, you have to multiply with its conjugate pair, meaning the two terms have to be the same. The only thing that should be different between them, so these two terms should be exactly the same. The only thing that should be different between them is the sign in the middle. You work with the opposite sign. Now for the example number 1, remember we have already done this question in the previous video and the answer came out to be root 5 plus root 3. We're going to do the same thing for this question over here. Okay. Now, very careful. This is something that I want to tell you guys to be careful about. We want to multiply this with the conjugate pair of the denominator. Okay. So even though these look like they both have the same terms here, it's the denominator's conjugate pair. So I'm going with, it's this one, right? So I'm going with root 6 minus 2. I'm picking this sign because this sign is opposite. I'm not paying attention to the numerator. And because I multiplied it with root 6 minus 2, I am multiplying the same to the numerator. I don't care what is here. It just so happens it is negative 6 minus 2, but it is completely irrelevant. We start by looking over here. We don't even look on the top. This is where you look at. This is root 6 plus 2. You multiply it with root 6 minus 2. And because of that, you multiply the top with root 6 minus 2. Exactly the same as the denominator. Okay? I am saying this again and again because I have seen students make the mistake of multiplying the top with its conjugate pair, which is wrong. Okay, so this is what you should be looking at. 1, then here, and then exactly the same thing here then. Okay, so when we do that, I'm going to do the conjugate pair, a multiplication for this denominator on the side here. So I notice that this is difference of squares. So I'm not going to FOIL it out. I'm not going to spend the time doing that. Then it takes away from your time that you need for other things. So it's always going to be a squared minus b squared. Okay, which gives me root 36 minus 4, which gives me 6 minus 4, and that's a 2. So my denominator here is a 2. And now I will work on the numerator. So which is root 6 minus 2 times root 6 minus 2. Here I do have to FOIL. So this is root 36 minus 2 root 6 minus 2 root 6 plus 4. So this is 6 minus 4 root 6 plus 4. I got 4 because I combined these two. Adding the like terms, the 4 and the 6 here, that gives me 10 minus 4 root 6. And again, I need to reduce it. So what can I take out from the top? I can take a 2 out. And it will reduce the 2 in the denominator. Sometimes it will happen, and sometimes you won't be able to reduce any further, which is just fine. But we always try to reduce it when we can. If you feel comfortable with this, please pause this video and try the last example. Otherwise, please continue with me as I do the last example with you guys. Okay? So for the last example, I will again do the same thing. I will multiply it with its conjugate pair, which is plus root x now. Same thing to the top. And then in the denominator, it will be difference of squares. So a squared minus b squared. 1 squared is 1, and I have x squared. So 1 minus the root of x squared is just x. So I get 1 minus x. In the numerator, because it's just getting multiplied by 1, it doesn't change anything. We can't reduce anything right now because I can't really take anything out of the top and the bottom to reduce them both. You cannot reduce this 1 and 1 because it has to be something that is common to both the binomials. So you stop right here.